Good afternoon all. So in the last session we have seen various properties and operation of fuzzy sets. So in today's session we'll see the problems on the fuzzy sets and its properties. Let us see that problem. Find the following for the given sets. The given sets are A and B sets. A is equal to 0.2 by 2, zero point 0.6 by plus 0.6 by 3 plus 0.8 by 4 plus 0.3 by 5. It means here at 2 point the corresponding value is 0.2. At 3 point the corresponding value is 0.6. At 4th point in A set the corresponding value is 0.8. At 5th point the corresponding value is 0.3. Okay, the corresponding value is indicated in the numerator and the corresponding point is indicated in the denominator. So here the remaining values, like you can write up to infinity also, but all other values are 0 means no need to represent those values. For example, here I have not taken 1 first point. That means we can write that first point with 0 as a value, fuzzy value as 0. The corresponding fuzzy function is at 1. That means 0 by 1 plus 0.2 by 2, like that we can mention. So but that I have not considered as it is 0, I am not considering that value. That's why I have started from 2 to 5, which are having some values. In a similar way, B set. In B set also, set A, set B. In set B also, at the same points 2, 3, 4, 5, the corresponding values are 0 0.3, 0 0.1, 0 0.7, 0 0.9. So we have A set, we have B set also. So A set is given, B set is given, and in the problem they are asking us to find out A complement, B complement, A union B. So these are operations on fuzzy sets, right? So A union B, A intersection B, A minus B, B minus A, and De Morgan's laws also. De Morgan's laws are nothing but A union B whole bar is equal to A bar intersection B bar. A intersection B whole bar is equal to A bar union B bar. So all these things we need to find out by using the given set A and set B. So here already we have seen with Venn diagrams how to perform these operations with the Venn diagrams. In the Venn diagrams, the resultant line, whether it may be upper line or intersecting line or union line, that's what we have seen with different colors in the last session. So here with the numericals, how that values will change for all these operations, that's what we will see. So first question is A bar, right? A complement, there is nothing but A complement. So in fuzzy functions, mu A bar of x is equal to, mu A bar of x is nothing but that is equal to, already we have seen this one, 1 minus mu A of x. Mu A bar is nothing but A complement, right? Mu A complement of x is equal to 1 minus mu A of x. Already we know the mu A of x function. That is nothing but the given set A. So here 1 minus of that mu A of x, whatever the set A is there, that if you write. So here if you want to represent that first point also means 0 by 1, like that you can mention 0 by 1 plus 0.2 by 2 plus 0.6 by 3 plus 0.8 by 4 plus 0.3 by 5. At the respective points, when you are doing the complement, you need to subtract from 1 the respective fuzzy values at the points. The numerators need to be subtracted from the 1 to get that complement. That's what here I have done. That means here I have taken only up to 5 points. 1 to 5 points only I have considered. So that points, if you are considering the first point also, I am including here 0 by 1. If you are including that point, then to get that A complement, 1 minus numerator is 0, right, at first point. 1 minus 0, 1. Second point, 1 minus 0.2, 0.8 by 2. 1 minus 0.6, 0.4 by 3. 1 minus 0.8, 0.2 by 4. 1 minus 0.3, 0.7 by 5. So this is a way how to get that A complement, the fuzzy operations. In a similar way, mu b bar of x is equal to 1 minus mu b of x. Already we know the b set that you can write, and you can do it in a similar way to the like A complement. B bar is equal to, again here you have to represent the b set, right? 1 minus mu b of x, mu b of x. In that place b bar, b you have represent, b function you have set. So if you subtract again numerators from the 1, then you will get 1 by 1 plus 0.7 by 2 plus 0.9 by 3 plus 1 minus 0.7, that is 0.3 by 4, 1 minus 0.9, that is 0.1 by 5. So now we got A bar and B bar. To find out that A and B, see here A bar and B bar is nothing but other than A we need to mention, right? In Venn diagrams, how you got it? A bar means you need to consider the other than A. If it is classical sets means, if you are drawing with circle means other than circle portion in the entire universe of discourse, in that rectangle box, what we have seen in that earlier sessions. So that is nothing but A complement, right? A means inside the circle, outside the circle A complement. So there the boundary is universe of discourse is that a rectangle box, but here maximum we can go up to 1 only, 0 to 1 only it is varying, right? So that's why we are subtracting that A values from the 1. Okay. Then you got A complement and B complement. Next A union B. To find out that A union B, mu A union B of x is equal to mu A of x or mu B of x. Union means here we need to do the fuzzy function or function, you need to do it. So here we cannot add directly, right? If you are adding like normal numerator denominators, if you are adding means you need to add the denominators also, or you need to do that mathematical operations. But this is fuzzy operations, that's why your denominators are only points, the points are as it is, and numerators only we are doing that operation with the numerators. So here A union B means mu A of x or mu B of x. A and B sets are mentioned. To get that union operation, union means we need to get the maximum portion out of both A and B sets, right? So that's what we have seen with Venn diagrams also. Maximum portion from the both A and B sets. Here at 2 point, from A you have 0.2, that is nothing but 0.2 by 2. In the B set you have 0.3 by 2, right? Which is more? 0.3 is more, right? So that's why you need to consider that 0.3 by 2 plus, in the first set again you have 0.6 by 3, in the second set 0.1 by 3. 0.6 by 3, 0.1 by 3, which is more? 0.6 is more. When you are going for union, you need to take the more common portion, more values. There is nothing but 0.6 is more than the 0.1, right? That's why 0.6 by 3. So even in the with that Venn diagrams, if you see, the more upper curve or upper line only comes into the picture when you are doing the union. When you are doing the intersection, the lower lines only have come into the resultant intersection of A and B sets. So here we are doing the same operation with the numbers, numericals. That means here if you want to do that union, you need to take the highest point, highest value at that point. The highest value at third point is 0.6. From the both sets if you see, one is 0.6 and the one is 0.1. At fourth point if you see, 0.8 by 4, in the B set 0.7 by 4. So which is more? 0.8. That's the 0.8 by 4. Next one is plus 0.3 by 5. In the A set plus 0.9 by 5. Which is more? 0.9 by 5. That's why 0.9 by 5. In the resultant A union B, you get 0.3 by 2 plus 0.6 by 3 plus 0.8 by 4 plus 0.9 by 5, which are nothing but more or higher values from both A and B sets. Which is higher, that can be represented in the A union B. If you do the mu A intersection, next one is mu A intersection B of x, which is nothing but mu A of x and mu B of x. Mu A of x and mu B of x. Here in the intersection, the least value is represented in the intersection. Least value is nothing but intersecting portion. Intersecting portion is very less portion. Union means you take the highest value at the same point from different sets. What are the highest value is there, that you will represent in the union as a resultant. In the intersecting, you need to do the least value. You need to take the least value. The least value, it is similar to the OR operation, right? OR and the intersection is, it is similar to the AND operation. If you take least value from that A and B, again the same values, right? Like in the A and B, whatever the set A and set B we have taken, that we need to do the AND operation. When you are considering a first set 0.2 by 2, in the second set 0.3 by 2, which is least. 0.2 by 2 is least. 0.2 by 2 is the intersecting A and B, the last line. And 0.6 by 3 from the set A, 0.1 by 3 from the set B, which is least. 0.1 by 3 plus 0.1 by 3 in the last line. So likewise, what are the least points are there? That's what I have considered. From 0.8 by 4, 0.7 by 4, 0.7 by 4 is least. 0.3 by 5, 0.9 by 5, 0.3 by 5 least. So your A intersection B is equal to 0.2 by 2 plus 0.1 by 3 plus 0.7 by 4 plus 0.3 by 5. These are the least values from the both set A and set B at respective points. If you take it first point, there is nothing but by 1. Both are 0 only, that's why no need to represent. Or if you represent also, you get 0 by 1 plus. That's it. The next one is A difference B or A minus B. A difference B, if you want to find out, what do you need to do? A intersection B bar is equal to A minus B, right? That's what we have seen in the last session. So A intersection B bar, already we find B bar and we know the A also. If you write in the fuzzy functions, mu A intersection B bar of x is equal to mu A of x and mu B of x. Mu A of x already A set, you know that you can write as it is, and next one is mu B bar of x. So already B bar we have find. So here itself the second one is B bar, the same values B bar, you can take it here. Again it is similar to the A and B, which is least, that we can represent. So at 1 in set B, if you see in set B at first point we have one value 1 by 1, right? But in set A 0 by 1 is there. That is not represented, but that is not indicated here, but 0 by 1 is there, right? So which is least? 0. 0 by 1 plus at 2 point, 0.2 is the least, right? 0.2 by 2 plus at 3 point, 0.6 by 3 from set A, 0.9 by 3 from set B. So 0.6 by 3. Likewise, if you take the least points, you will get the A intersection B bar, which is equal to A minus B. You will get it as 0 by 1 plus 0.2 by 2 plus 0.6 by 3 plus 0.3 by 4 plus 0.1 by 5. In a similar way, B difference A or B minus A, which is equal to B intersection A bar. A bar already calculated, B you know. A bar is nothing but first problem. We have calculated A bar only. So mu B intersection a bar of x is equal to mu b of x and mu a of a bar of x. So if you write that b set and a bar set, again you need to do the same intersection. Intersection means least points you have to mention. Least values at 2, 3, 1, 2, 3, 4, 5 points are represented with 0, 0.3, 0.1, 0.2, 0.7 as a resultant B intersection A bar. So that you can get it from the just by doing that intersection operation between the B and A bar, which is nothing but least values from that at respective points. Next, to find out the De Morgan's laws, again if you understand that first two problems, there is nothing but first and second, A complement and B complement, A union B, then A intersection B. The remaining are in a similar way. Union means you have to take the higher values, intersection means you have to take the least values, that's it. Here A union B as a De Morgan's laws, A union B is equal to A bar intersection B bar, and A intersection B complement is equal to A bar union B bar, right? So first we'll see the A union B whole bar is equal to A bar intersection B bar. There is nothing but mu A union B complement of x is equal to mu A of x and mu B of x. So already you know you find A union B. A union B, you got it by doing the union between the A set and B set. That is nothing but highest values from that A and B set you have taken, and the resultant A union B is equal to 0.3 by 2 plus 0.6 by 3 plus 0.8 by 4 plus 0.9 by 5. If you want to do the A union B complement, if you want to find out that A union B complement, simply it is nothing but A complement like. So A union B complement is nothing but mu A union B complement of x is equal to 1 minus mu A union B of x. Already you know the A union B. Just you need to subtract that from the 1. When you are doing that, A union B bar, A union B whole bar or A union B complement is equal to 1 minus, at first point we have 0 1, right? 0 by 1, right? That's why 1 minus 0, 1 by 1 plus again 1 minus 0.3 by 2, 0.7 by 2, at 3, 1 minus, you have 6.6, right? So 1 minus 0.6, 0.4 you get it, 0.4 by 3 plus 0.2 by 4 plus 0.1 by 5. So in a similar way, so this is just by doing that A union B whole bar you calculated. Now you can do it individually. On the right hand side you have A complement intersection B complement, right? So that also you can do it. A complement already got it from the first problem. B complement you got it from the second problem. If you are doing AND between that A complement and B complement, there is nothing but mu A complement of x and mu B complement of x. You need to take the least values from that two sets, right? When you are doing that A complement and B complement, A complement and B complement is equal to 1 by 1 plus 0.7 by 2 plus 0.4 by 3 plus 0.2 by 4 plus 0.1 by 5, you get it. So if you see that two boxes, both should be same, right? First one is you have done with A left side. The left side is nothing but A union B you calculated. Then A union B whole complement you find. So that should be equal to the right side part. Right side part is nothing but as per De Morgan's law, A complement intersect B complement, right? So that you are doing with the last box. The resultant of A complement and B complement is nothing but last box. So both the boxes are same. That means hence A union B whole complement is equal to A complement and B complement. That's what we got. De Morgan's law. As per De Morgan's law, we got the correct result. So if you understand that how to calculate that intersecting means, so yeah, intersecting means you have to take the least values at respective point. Union means you have to take the highest values at the respective points in different sets. And complement means you have to subtract from 1. That's it. If you know these three things, you can do these problems. So in a similar way, the second De Morgan's law is A intersection B whole complement is equal to A complement union B complement, right? So in a similar way to like first De Morgan's law, you have to do it. That you do it as a homework. In the second homework problem also, so I'll read out the problem. The task here, the problem is the task is to recognize the English alphabetical characters F, capital F, E, X, Y, I, T in an image processing system. Define two fuzzy sets. One is I. Here I, that is not I bar. So that is not complement. Simply that is represented with I function fuzzy set. I and F to represent the identification of characters capital I and capital F. I function and F function to represent the identification of characters I and F. So now I function here in this problem I have represented that complement is with C. Superscript C represent the complement. Okay. I fuzzy set is equal F comma 0.4, E comma 0.3, X comma 0.1, Y comma 0.1, I comma 0.9, T comma 0.8. And F fuzzy set is equal to F comma 0.9, E comma 0.8, X comma 0.1, Y comma 0.2, I comma 0.5, T comma 0.5. So these two fuzzy sets are there. Now you have to find out the I union F. That is not complements. I not I complement and F complement. That is just I fuzzy set. It is represented in few literature. It is represented like that fuzzy set. I union F. Second question is I difference F. There is nothing but I minus F. Third question is F union F complement. Here if you see the C problem, F union F superscript C. Superscript C is represented with complement. F union F complement, and also verify the De Morgan's law. That is nothing but I union F overall complement is equal to I complement intersecting F complement. And second one is I intersecting F complement is equal to I complement union F complement. This you do it as a homework so that you'll understand in a better way. So like how you have solved that earlier problem, in a similar way you solve this problem. In a similar way, for example, if you take I union F, first question is I union F, right? I union F, if you want to take it, I mu I of X or mu F of X, right? So which is having higher value at F point. Earlier we have mentioned with 1, 2, 3, 4, right? Here it is represented with some alphabets. Yet F point, which is having higher value, 0.99, right? I union F is equal to F comma 0.99, E comma 0.8, X comma 0.1, Y comma 0.2, I comma 0.9, T comma 0.8. From both I and F, which are having more values that I have considered, that is equal to the I union F, right? So in a similar way, you do the remaining problem. Thank you.